cleared them, we put them back in the rack and put them back together. Man, it was quite interesting.
Oh, I'm sure it was. Absolutely.
But he said if you'd have been standing in front of that, it would have just totally cooked you.
I don't doubt that.
He said that was a plasma fire
Mm-hmm.
that you did not want to be around.
Well, that's what I was talking about earlier. You know, this stuff is just
It will take you out.
unbelievable. Yes, sir. Okay, let's go ahead and.
Move on.
This is a PM 850. And without going into every slide, I'm going to show you right here in the front everything that I can, tell you everything I can about it that you really have to know. You're going to see 4 lines of information displayed on it at all times, like this. Okay? And you're going to see this little menu here there at the bottom. You see this arrow to the right?
Yeah.
That means that you have more menus or selection on it. And that is the biggest, I don't know, it's not a problem, but that's the biggest challenge to overcome when it comes to this power meter and then our circuit monitor 3000 that's in here, the same thing, is knowing the menu structure. Once you know the menu structure, then you know what you're looking for. Once again, this is actually like the multimeter.
Right.
Knowing what you're looking for or what you want to do. You have amps, there's volts, harmonics, you name it. There's a lot of stuff in here, a lot of information. And it'll actually default to this summary screen if you don't touch it after, I think it's a certain amount of time, whether it's 3 minutes, 5 minutes, whatever it is. And you'll see it in that summary. But and then the other thing is also the other arrow that it might have on here would be a little arrow pointing straight up here. Okay? So as long as you don't have any more arrows to the right like this, that means that you don't have any more submenus. But then you're going to have probably an arrow that points it up to the right.
Yeah, just scroll down.
Right. That means that you scroll out of it to go back up again. Everything. But everything is going to be self-explanatory. To see amperage, you'll go onto your amp menu. Volts, volt menu. And that's what I wanted to show you was, of course, the physical characteristics and where the stuff plugs into it. Number 1 is the control power supply connector. Okay? And control power connection for, there's a schematic on there to show you as far as control power. But it takes power directly, I was telling you, directly right off the bus. So if it's 480, it'll take 480, so you don't need PTs. So it makes it very simple, very easy to go in there. You know, line 1, line 2, line 3, neutral, and ground. That's not control power though, I'm sorry. That's a monitoring power. But control power can take actually, it'll be off of, you can do it 2 ways. You can go through a CPT, or you can go from the, and it's got to be less than 385 volts though if you go direct. So you would end up, for control power, you could use a CPT or use one leg from your monitoring voltage, which would make it like 277 or something like that, and then a neutral.
270.
Right.
It hurts.
Yeah. So essentially that's what you would use there, or it might be that it combined 120 if you were using control power. 120 or 220 if you use 2 legs of control power. Number 2 are your voltage inputs, and there's the 3 phases that I was talking about coming directly from that. I was confusing control power with your voltage inputs. Voltage inputs come directly without having to go through CPT of any kind, up to 600 volts. Okay. 3 are your input-output connectors. And then on the bottom, oops, let me back it up. The bottom view, you'd have number 5, or excuse me, 4. It says it's the heartbeat LED. And what it means by the heartbeat LED is if this display is not on, check to see if that LED is lit. If that LED is not lit, check to see if you got control power to it. Because if you don't have control power going to the, you might not have that display or that LED's not, meaning that there's no power to the unit itself. And then you can check the fuses that feed that control power if you don't have control power there. So you want to find out why you don't have control power. So if you go to your CPT and you say, okay, hey, I've got primary, or the primary side of my transformer, I got power coming there. It's not on my secondary, my CPT. Then maybe my fuse is leading down to it. Okay. Then 5 right in here is the RS485 COM port. 6 is the back view. So bottom view is talking about down here, back view is back over here in the back of it. Optional module connections, right here 6, and then 7 of the current connectors, or current inputs, which are your depending on how you label your CTs. So CT1, CT2, CT3, or X1, X2, and then B phase X1, X2, C phase X1, X2, whatever.
Coast, he's in his office.
That's it.
These are some of the features. It is a true RMS meter. It's a revenue grade accuracy. Let's see, class revenue accuracy. I misstated. I said 0.01%. It's actually 0.075%. 75 versus 100. No, 75 makes it. See, there's a lot of information in there for this meter. Once again, there's a lot of features. What do you want from it? Okay, and the majority of the time that you're using it, I don't know that you even utilizing it for monitoring purposes. And I'm talking about monitoring from a remote location, because you could have those, those circuit monitors, including the power meter that's in front of, or not the power meter, but the trip unit on the breaker that's out there on the medium, on the low voltage switchgear. That could actually be via the power logic program to be able to be displayed, or you can see it, or you can monitor it from a remote location, meaning like your control room, like a SCADA, or your control room, exactly, yes, that you're able to be able to see it and everything. And said, okay, because you're communicating with it out in the field and stuff like this, so you don't, if you want to take readings and everything, you can actually take them from there versus going out in the field. So everything you can do in the field, you can actually see from a remote location if you got it set up that way. Alarm and data logging. And here's what I just told you about earlier. It's going to explain every detail of this power logic in here. But really, like I said, all you have to be concerned about, the most important thing to me is, okay, the menu, here's a little arrow telling about, okay, return to the previous menu. See, that means that, okay, so you still have a sub-menu there, and then you're below a menu above you, so you don't know how many menus might be above there, but you know you have one above you, and then you still have some more below you because of there. And that's when you see that and notice that, that's really all you have to know and understand, because how the buttons work. And what I wanted to see is this, the overview. There you go, right there. See level 1? Remember we showed you the amps? Yeah, so you got 1, 2, 3, 4, 5, 6, 7, 8, 9. I think it's got about, well, oh shucks. I get confused on these things. I know that some of these have 7 sub-menus. Or, excuse me, like in level 1 you have 7 menus. And then out of those 7 menus, some will have sub-menus that have 7 selections. So you can, you know, depending on what level you're going to go to. So like the amps, you can go level 1 to level 2, and under amps you're going to define as far as the amps per phase, amps demand, and then the amp unbalanced amps. Voltage is going to be line to line, line to neutral. So you have 2 submenus there that are going to show you those values. The power, you're going to have power, the phase, power per phase, and then power demand. Then you got energy, which is the kilowatts or megawatts or whatever, or is it VAR? Energy is VAR. I can't see. No, it's VAH. That says VAR there.
VAR1.
Yeah, VAR. And then power factor, true or displaced, hertz.
VARH.
Yeah, VAR-H, right. But anyway, look at your level and what is beneath it, and then you know what you can find easier that way. There's also supposed to be a maintenance menu, and it doesn't show it on here, but see, because it says maintenance. Password is default is 0. On this meter and the circuit monitor, the CM3000, it's the same password. I deliberately did this one because the CTs, if ever you have to replace them, which would be the same, that would be the main thing that you would have to set up. If ever the body, or you have to replace the meter, that's one of the things you have to set up as the CTs. Otherwise, you won't be able to read any power out. And if you ever see zeros or anything, always go in here. Or if you don't have an amperage reading, first thing you want to do is check to see if the CT has been set up. Because if the CTs haven't been set up, it's going to read 0 amps. And you think that it's dead. And you got voltages, but there's no amperages. Like I said, what's going on? Go in there and check to see if the CTs have been set up. And it's real easy because you go into the setup menu, you do the zeros, then you go to CTs. When you hit CT, it's going to show you the CT primary. And then you'll scroll up or down. And this is what this little arrow is going to be, up or down. One of these two. We'll make it count. And then it'll flash actually one number at a time. So let's say if it's the first digit starts to flash, if it's 1,000 to 1 or whatever it is, or 500 to 1, you bring it up to 500, and then you hit OK, and then the next digit will start to flash and so forth. So once you hit them all, so when you hit OK, then come back and it'll start as far as the secondary. And the secondary, then you hit OK again. So you've actually gone through each individual, hit OK, now you're going to back up. See, like I said, there's a meter, and then you CT's meter, go into CT, enter the primary CT number, press OK, the secondary CT number, OK, press OK, or to return to the setup screen, and then you press again to get out or to save the changes. PT ratio is basically the same thing, but it's the scale is 1 to 1 because the primary is 120, the secondary is 120. So essentially, it's getting it directly from the frequency, the same thing. Those are the 3 main things. More so important is the CT. Meter type, a 3-phase, 4-wire system with 3 CTs, 3 PTs. They call that a 4-0 system. We used to have to kind of know these by heart, or have to pull the book out each time, because it could be a 3-wire system, 3 CTs, 3 PTs, or it could be a 4-wire system with 2 CTs and 3 PTs, or it could calculate B phase using A phase and C phase CT and calculate B phase current. And the same thing with the PTs, or it could be 3 CTs with 2 PTs and so forth and so on. So it was crazy. There's really no maintenance on this. The troubleshooting is, I told you about it, how you would find out if there's any power to it. That's basically it. I mean, it's very simple.
Question, do
Yes.
they, can they repair these? If you have one go bad, and we send it back to just throw away unit?
Yeah, yeah, everything is made disposable nowadays, unfortunately.
Okay.
That's the sad thing about it, to be honest with you. I wish that it just, for them, not cost effective.
Yeah,
I mean, because the modules and stuff like that or whatever goes bad with them, it's just, they're irreplaceable. I mean, it's easier to replace the whole deal. Everything that is made modular.
yeah.
So,
Okay. Thought I'd ask, because I know we've had a lot of, historic drives that were, they had failed, and we'd send them back, and we'd get them repaired.
the drives are a little bit different.
Yeah, but,
Yeah,
I've got, Flight puts out a module submag. They call it a submag, but they said if I'd send the old ones back in, they'd get them repaired. So, I didn't know if this was
No.
similar to that.
no, unfortunately, well, not to my knowledge, and maybe I shouldn't be so quick to speak of things.
Yeah,
There might be a mom and pop shop that actually
can do it.
right. But for them, or for us, for Square D it's large conglomeration, or better yet, not what Square D is Schneider Electric.
Right.
If you're talking about a $4,000 or $5,000 unit
Yeah,
compared to the billions, this is just not,
yeah.
it's just not feasible.
It's not feasible.
Yeah, it's not feasible for them at all. It's like, okay, no, we don't even bother with anything like that. Where, like I said, $4,000 or $5,000 for a mom and pop shop and everything else for them to repair it is $200 or $300. Then for them it's a different story.
Yeah.
But that's something. Then of course what you're looking at is you no longer have the guarantee or the warranty as far as Square D at that point.
You may have it fixed and
It'll
it explode on you when you put it back in.
right, and that's the thing that you're taking into your own hands and stuff like that. So that's why.
Okay.
We don't kind of, when we have it, we're backing it up and everything else, we're gonna take care of you and everything else, whatever. And there's your troubleshooting chart as well. Again, everything's always towards the back and everything else as far as the chart. So it'll give you, as far as whatever potential problems you have and the causes and so forth, you're able to go into, and then how the possible solutions, problem solutions. You got 2 pages of it and everything else. Close this one up. And actually, the next one was what is it, logo, or,
Power Logic CM3000.
is that what it says on it?
Like section
It's
5.
Actually, is it tab 5 or tab 4 we're on?
I thought we just finished 4.
Yeah, that's why we're just on 4.
Okay, wait a minute.
Our Logic CM 3000.
Oh, I know what I did. I jumped to the Power Logic PM 800. I'm sorry, and that's actually tab the last one.
Oh, okay.
I'm sorry. Yeah, I grabbed the wrong thing. Okay, I didn't go by the book here because I should have gone. Okay.
Well, that's where I got lost.
Yeah, I'm sorry. Well, what I did is actually I had pulled them out here, and as I closed them, whatever came up is what I went by.
Right.
And that was my fault. I'm sorry. I didn't even stop to think about the book or anything anymore. Because I was just covering it. This medium control voltage control we've already gone through this, but I will show you some things here real quick. So you could see it. You're seeing again. Wow, now it's starting to get a little bright here. Maybe I could turn these lights off a little bit here real quick. Where are they having that? The sunlight coming from the back. Yeah, it's a little bit better there. Just makes it a wee bit better. See, again, you can see the compartment and everything else as far as its full voltage, non-reversing, that we had a little while ago we showed you. That got the little tray in this.
Right.
this is a starter with a contactor and everything else, essentially here, excuse me, and that was that medium voltage motor control center we're talking about versus medium voltage line interrupter HVLCC versus the motor control center, which is why that's why they call it motor control center, because you had a contactor in there that's sort of like for motors and stuff. So but the front, this is what I was making sure that, you know, not confusing that HVLCC with this, because when you think about it, you have the same kind of structure at the top here, okay? And you have your fuses, but you have your motor control or contactor down over here. Where the HVLCC, you have this, and then you don't have this bottom part here. Remember? So, not to confuse one with the other. What I wanted to show you the difference between is you have this area where you actually use for the cable tray and stuff like that, where your load wires and stuff like that can go into here. So that's why they call it motor MCC, motor controller, versus HVL, which is a high voltage line interrupter. And the CC part of it is because, once again, it's that enclosed isolation switch. See, now this is a side view of it. And the difference between the HVL and the MCCs is that the HVLs don't have any controls, where the MCC does have controls, because you do have, as far as, but essentially this stuff is about the same. The isolation means a little bit different, because on the motor control center versus the ICs, because this is the isolation means it was right here versus the contact on the motor control center there. And the HVL switch itself was that encased thing also, but it's a little bit different than this one,
Right.
when we saw that cutaway view of it. But there again, like this, there on the back side, now you can see the sideways under this. Once again, here's the, there's that little trolley, contactor, and how it goes from there to there, and then from there your load wires will go from there, and then your line side will be coming in there to the top, feeding that through the fuses, which would be like more or less on the back side over here. And those fuses come in there and bring it to that. So it's kind of a little bit more, that's a bit more complex than this one. It was cut and dry, where you had the fuses, or the lines that come in there to the top, the bottom of the fuse. I mean, top of the fuse on the bottom of this, the epoxy, and then the top of the fuse directly to your load wires that would go straight out to whatever. So you didn't have that contactor in there. So it kind of simplified it more than anything else. There's all we do is just show you some of the withdrawal position. I mean, and that it's showing you a color. Basically, the thing we've already seen. The options is that C-PAN I was telling you about.
Right.
Low power current transformer, and these are the circuit monitors that you could have. The PM 800 series, 820, 850, or an 810. Basic power metering quality. This is a little bit higher up the scale. You apply to the mains, they're applied to critical power. And once again, this is what the features of it. Power distribution detection, outboard data logging, waveform capture, and this one's a little bit more sophisticated, the CM4000, 5000 that they have. Transient wave shapes, variety of I/O options, and it's the highest revenue accuracy, GPS time synchronization, and so forth. So I mean, it's the higher the number, the more options you have, because people are asking for it. So they, they're just putting it out there. It's like vehicles, the same thing. You keep getting cars now that they do themselves. They talk, they honk, they drive, they park themselves. That's right. So it's ridiculous, but it's there because people want it. It's made available to them. Here's the kind of structure that it actually has. Here's the frame, the housing, and then this is the door, how it interlocks under. So you can actually see that it even has like foam in there as well. So it's a structural wise, it's a real good and secure door. And it does, it's like it says 8-point latching door, it's got these little hooks, 8 of them puppies. And it's almost impossible to get those unless this switch is open, and if this switch gets locked and this mechanism gets messed up, then we have to take that mechanism off of there. But to take that mechanism out of there, you have to have the door open to be able to get those screws. So
So
it's,
you're screwed.
it's a challenge. We've done it. Believe me, we've done it, but it takes some doing. It takes some doing. And
Engineers get too smart for themselves.
it's for themselves at times, right? So the FSRs have to become ingenious as well and figure, okay, how am I going to open that thing? And the secret of it is once you open or you lift that up with the handle, you're able to lift it up and everything else. Once that lifts up, then it's a no-brainer. But there's a rod with this thing being in the closed position that doesn't allow it, and these things all interlock. So it is kind of catchy and everything else. It's got these little pressure relief flaps, which is pretty neat.
Yeah.
So in the event that, plus it keeps any kind of dust from going in, but it allows it to go out and it blows it off. So like I said, people actually start to sit and think about how to do this stuff and everything else. You'll have live line indicators, and they are actually LEDs, and they have also blown fuse indication for tripping as well. And then they got a temperature monitor as well. That's done through fiber optics. So these are all options that are available. Not necessarily that you'll have them. Also with the temperature monitor, that is also done through fiber optics or sensors. Get rid of each one at a time. I don't want to say. There we go. QED power. That's actually should have been at number 4. And that's the board that I was talking about that you actually have out here, low voltage. And here's your other, this would be your low voltage clock right here. That would be, here's where your main would be for this one, with these other feeders. And then these breakers would be these breakers right there, then they'd go feed something else. They might go to another, it could be an MCC itself somewhere else, or another little panel board, or even if it's a panel board, then you have individual breakers in that panel board and so forth, with the main and stuff.
Now these breakers in these, they have a little module.
This one here. Yeah, this is the one I was talking about.
Yeah, there's a little amperage module
Yeah,
that
that's-
plugs in the front of the breaker.
Right. That's the one, and that don't have any, I mean, it's not even